So, in understanding how a population may grow, how the numbers of individuals in a population may rise or fall, it's important to understand the life history, which is the product of natural selection. So, an organism's life history, besides just being looking at when is it haploid, when is it diploid, considers when does it survive, how many offspring does it produce, uh, and these life history patterns are the product of evolutionary processes that direct development, physiology, and behavior in different organisms. So when we talk about life history in an ecological sense, we are interested in knowing the age at which reproduction begins, how often the organism is going to reproduce, and how many offspring are produced per reproductive episode. Isn't that kind of an interesting way of looking at it? Reproductive episode, or if offspring are produced, how many? Do they have litters? Do they produce thousands and thousands of little tiny baby larvae, like in the oysters? Is it just a single live birth? How many eggs does a hen lay on any given day? So on and so forth. There are a number of species that exhibit what's called Semel Parity. They only reproduce once in their lifetime, and then they die. So think about salmon, the fish, the tasty, delicious salmon fish. They are born in freshwater rivers, and as they grow and mature, they will swim towards saltwater, oceans, and seas. They will develop and mature in those oceans and seas, and then they'll return back to their home freshwater channel, their creek or river or stream or whatever it is that they were born in, where they will spawn. And then after they spawn, they die, and the eggs just develop. They don't require parenting. So that's an example of Semel Parity, Big Bang reproduction. Only once and then die. But then, in contrast with that, we've got Iteroparity, repeated reproduction. So iteroparous organisms can reproduce repeatedly, and that's what we do. You know, if you have brothers or sisters, it is the result of iteroparity. So for most organisms, it's one of these things. So even if you're an only child, if your parents didn't die after producing you, that's not really Semel Parity, because they have the potential, at least, for iteroparity. So Semel Parity comes from Semele, who it was a Greek goddess who reproduced only once. Iteroparity, think about reiteration. If I reiterate something, I'm repeating it. So iteroparity means repeated reproduction. So if you have a highly variable environment, it's likely that you're going to undergo Semel Parity. But if you have a fairly consistent environment, you're going to have iteroparity. So here is an example of a semmelparous organism. This is an agave plant, or a century plant, which we have agave around here, which doesn't reproduce in quite the same fashion. We have a more consistent environment. But out in the desert, this century plant can live for a very long time. That's where it gets its name, century plant, before it produces this great big inflorescence, a whole bunch of flowers. It produces hundreds and hundreds of flowers on this inflorescence, which will get pollinated, and after they're pollinated and seeds are produced, this plant will die, releasing its seeds into this desert environment. And if the environment is favorable, you will get new seedling century plants growing. Here, for example, is iteroparity in action. Here's mom, here's brothers, and here's new baby. So she has reproduced multiple times. Repeat reproducer. I wonder if she had any idea when they took this picture that she's going to be used to represent repeat reproduction. I'm guessing not. So why do organisms exhibit semel parity or iter parity? Again, it has to do with the environmental constraints, and there's evolutionary constraints. It is more adaptive in less stable environments to put all of your reproductive output into one great big reproductive effort. Whereas if the environment is more consistent, iter parity is more favorable from an environmental standpoint. But life histories are often the sum of trade-offs, because there are finite resources out there. There's only so much food, only so much space, only so much water, only so much of the essential minerals that you might need in the soil if you're a plant, that are going to force you to trade off between survival and reproduction. How much energy do you put into survival versus how much energy do you put into reproduction? So in European kestrels, for example, there is a trade-off between survival and paternal care.